Hi everyone. Today we'll see the two-port networks. Coming to the introduction of two-port networks, a network may be used for representing either source or load or for a variety of purpose. That is called network. Network contain multiple elements, sources, loads, and that can be used for any purpose. A pair of terminals at which a signal may enter or leave a network is called port. For example, if you consider this as a network, in this network inside you have multiple elements like a resistor, inductor, capacitor, combinations of sources, and among them if you pull two terminals, these are called one terminal, this is one dash terminal, and like pair of terminals means these two are called the pair of terminals at which the signal may enter. From 1 the signal may enter, from 1 dash the signal will leave. For this single port network, this is called single port network. Two terminals are called the one port, that is connected to the one network, that is called single port network. A port is defined as any pair of terminals. A port is defined as any pair of terminals into which the energy is supplied. Energy or signal can be supplied, or from which energy is withdrawn, or where the network variables may be measured. Network variables means I'll assume this as voltage between these two terminals and current enter into this terminal, or current leaving from this terminal, or network current enter this network and leaving from this network, where the variables are measured, that is called port. In a similar way, if two port means for the same network, for one side I'm assuming two terminals, this is one port, other side the other two terminals 2 and 2 dash, that is called second port. So the first port is called, if you consider it as input port, the second can be output port, or if this is output port, this can be input port, or both can be input ports based on the passive or active. If you have source means one side, if you have source means other side you may have load, like that. Okay. In the input port side, I am measuring the variables V1, I1, and port 2 variables I am measuring V2, I2. Instead of considering input output, port 1, port 2. So that can be act like anything. This is called port 1 and port 2. That's why V1, I1 at port 2, V2, I2. So two port network is simply a network inside a black box. Inside the network we have, inside this box we have multiple elements. Such a building block is very common in electronic systems, communication systems, transmission and distribution systems. Out of this box we'll take two terminals or multiple terminals, and we can use it for the multi-purpose, like we can connect the source, or we can connect the load, or we can connect one more source, like that. So you can see such applications in electronic system, communication system and transmissions and distribution systems. Two ports containing no sources in their branches are called the passive ports. If there are no sources, then that is called the passive ports. Among them are the power transmission lines and transformers. Generally, power transmission lines means simply this is phase wire, this is neutral wire. I'll assume this portion, particularly any particular portion I can assume as a network. You don't have any source, simply the power is transferring from the port 1 to port 2. The two ports are containing source in their branches are called the active ports. If there is any source present, that is called the active ports. And we have few combinations or few parameters to measure. So to start with, we'll start with the open circuit or impedance parameter, or open circuit impedance or Z parameters. Impedance is denoted with the Z parameters. So as a first step, you have to draw the two port network. So this is your network. This is your network, and port 1, port 2, port 1 variables are V1, I1, V2, I2 are the port 2 variables, 1, 1 dash are the terminals at the port 1, 2, 2 dash are the terminals at the port 2. This is the first step. To represent the Z parameters are expressed by the port voltages. That is, port 1 voltage is V1, port 2 voltage is V2, V1, V2 in terms of the currents at port 1 and port 2. So V1, V2 are represented in terms of the I1, I2. To know this, Z parameters are open circuit impedance parameter. Why we call that as a open circuit impedance parameters, that we'll see by the end of this session. Out of this, if you want to express this V1, V2 in terms of I1, I2, V1, V2 are the dependent variables, I1, I2 are the independent variables. So V1 I need to express in terms of the I1, I2, and V2 also I need to express in terms of the I1, I2. So V by I is nothing but impedance, right? That's why the coefficients of that corresponding currents are called the impedance parameters. In the first equation, if you see, this is as a second step, we are representing the V1, V2 in terms of the I1, I2. So V1 is equal Z11 I1 plus Z12 I2. This Z11 I1, Z12 I2 are the coefficients of this I1, I2 currents. Those are called the Z parameter. In a similar way, if I represent the other voltage V2 in terms of I1, I2, the corresponding coefficients are Z21 and Z22. So this is your second equation. I can express the same equation in the matrix form, like V1, V2 are expressed as a 2 by 1 column matrix, and all these coefficients, Z parameter coefficients, Z11, Z12, Z21, Z22 are represented as a square matrix, impedance square matrix, and I1, I2 are represented as a 2 by 1 column matrix. If you multiply these matrices, you will get the same equation. V1 is equal to Z11 I1 plus Z12 into I2. V2 is equal to Z21 I1 plus Z22 into I2. So overall, I'll consider this vertical voltage matrix as V, square matrix as Z, column matrix of current as I. V is equal to Z into I. As per Ohm's law, voltage is equal to impedance into current. Okay. So if you see here, how can we find out the individual Z parameters? You have two equations and two variables. By substituting I2 is equal to 0, the second term will become 0 and your equation will become V1 is equal to Z11 into I1. Out of that, your Z11 is equal to V1 by I1. By substituting I2 is equal to 0 in the second equation, V2 is equal to Z21 into I1. So Z21 is equal to V2 by I1. In a similar way, if you substitute I1 is equal to 0 in both the equations, this first term will become 0. So that you will get V1 by I2 is equal to Z12. V2 by I2 is equal to Z22. So those things I have written in the next page. So Z11 is equal to V1 by I1. By substituting I2 is equal to 0, you will get this equation. And in a similar way, the other parameters. So what is this called? Z11 is equal to V1 by I1. I2 is equal to 0 means I can call this as at I2 is equal to 0 means we are using the port 1 variables alone. That's why. And all these ratios, if we see, Z11, Z21, Z12, Z22 ratios, voltage by current only, right? That maybe belongs to the one port or other port, but voltage by current ratio. That's why it is called impedance. And the driving point impedance at port 1, we'll call this V1 by I1 as driving point impedance at port 1. Why port 1 means these two belongs to the port 1 variables only, and moreover we are substituting I2 is equal to 0 means port 2 current equal to 0. That's why we are measuring the impedance at port 1. Or we can call the same parameter as open circuit input impedance. Why we call it as open circuit input impedance means I2 is equal to 0 means open circuit, current is equal to 0 means open circuit. Both parameters are V1, I1 belongs to the port 1 only. That's why it is input. V by I means ratio of the voltage and current is impedance. That's why open circuit input impedance. Z21 is equal to V2 by I1. When you substitute I2 is equal to 0, this is called transfer impedance at port 1. Again, by substituting I2 is equal to 0 means both belongs to the port 1 only. Why it is called transfer means the denominator to numerator, if you see, first port variable to second port variable, that's why it is called transfer impedance. And moreover, it is called forward transfer, port 1 to port 2, that's why it is called forward transfer impedance. And or we can call it as open circuit forward transfer impedance. Why we call open circuit means current is equal to 0. Why we call forward means 1 to 2. Why we call transfer means as it is transferring or it belongs to one port to other port, that's why it is called open circuit forward transfer. Forward means 1 to 2, transfer means port 1 to port 2, that's why. And impedance means voltage by current ratio. In a similar way, Z12 is equal to, by substituting I1 is equal to 0, you will get the Z12 and Z22. I1 is equal to 0 means V1 by I2 will get it. If you see here, it is 2 to 1. 2 to 1 means it is reversed and transfer only because one port to other port. Again, impedance only. Again, it is open circuit only. That's what it is called. Open circuit. I is equal to 0. Open circuit. Reverse because 2 to 1. Transfer because one port to other port. Impedance because voltage to current ratio. Or we can call transfer impedance at port 2 because by substituting I1, port 1 equal to 0, port 1 current equal to 0, that's why at port 2 only. The second Z22 also, by substituting I1 is equal to 0, that's why it is called at port 2 only. Z22 is equal to V22 by I2, V2 by I2. V2 by I2 means open circuit driving point impedance at port 2 because I1 is equal to 0. Or we can call it as open circuit output impedance. I is equal to 0, that's why it is open circuit. Output means port 2 parameters both are, impedance means V by I ratio. Open circuit output impedance. In the same two equations, if you see, so what are the two equations? V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. How can I represent these equations in the pictorial form? So V1 is equal to Z11 I1 plus Z12 I2 means V1 I have represented between the two terminals 1 and 1 dash. I1 current is entering into this network. I1 need to be multiplied with the Z11 to get the first term. Z11 into I1. If you see the second term, it is Z12 into I2. Z12 I can represent here, but I2 current I will not get it in this loop, right? So that is belongs to the other port current. That's why I have represented that as a dependent current source, like I2 current dependent voltage source. Directly I have written Z12 into I2, Z12 into I2 as a voltage source. This current belongs to the other port. That's why it is called current dependent voltage source. And close this loop. If you see, if you apply the KVL to this loop, V1 is equal to Z11 into I1 plus Z12 into I2. First equation we got it. In a similar way, V2 is equal to Z21 into I1 plus Z22 into I2. Z22 into I2 means it particularly belongs to the second port only. That's why Z22, the current enter into this port is I2. I2 into Z22, second term we got it. To get this first term, it belongs to the port 1 current. That's why I am representing that as voltage source, current dependent voltage source. That current is belongs to the first port. Z21 into I1, current into impedance is nothing but voltage, and current dependent voltage source, that current belongs to the port 1. If you apply KVL to this loop, V2 is equal to Z22 into I2 plus Z21 into I1. We got second equation also. And further, if the network under study is reciprocal or bilateral, then in accordance with the reciprocity principle, what is the reciprocity principle? Voltage to the current ratio or response to the excitation ratio should be same even if it interchanged. If I consider V2 by I1, it should be equal to the V1 by I2. Instead of V2, if I consider V1, the response should be, instead of current I1, it will become I2. If it becomes same, that is called a reciprocal. V2 by I1 I'll get by substituting I2 is equal to 0. V1 by I2 I'll get by substituting I1 is equal to 0. If both are same means Z21 is equal to Z12, then it is called a reciprocal. And all the parameters have dimensions of impedance, because all those parameters, if we see, voltage to the current ratio only, right? That's why it is called impedance dimensions only. The individual parameters are specified only when the current is current in one of the port is 0. By substituting I1 is equal to 0 or I2 is equal to 0, you will get the parameters. That's why this corresponds to one of the ports being open circuited. Any one of the ports need to be open circuit to find out the parameters, from which the Z parameters also derive the name of open circuit impedance parameter. That's why we'll call it as open circuit impedance parameters. Out of this derivation, if we see how many steps we have, if you want to find out the open circuit impedance parameters, first draw the standard two-port network, express those parameters to find out this equation, voltages in terms of the current for the impedance parameters. That equation have written. Second step. Third step, by substituting to find out the individual parameter, you substitute the any one parameter equal to 0 to get that parameters. So now I got the 4 individual parameters by substituting I2 is equal to 0 and I1 is equal to 0. This is third step. Fourth step, you represent the equations as a figure form. This is a fourth step. So fifth step, if how it becomes reciprocal or bilateral, that you can check. These are the 5 steps involved in this Z parameters calculations. Thank you all.